Hello, Dave, Hammond Motorsports here in Dirt Car USA. Haven't been live lately. I've had a lot of stuff going on. I'm sorry, we just haven't had time to do it. And anyway, wanted to take a little bit of time, and I just want to take a little bit of time here and show some tips with our caster camber gauges right here, setup plates, and our squaring bars. And working with the car at ride height, working with the car in dynamics and at ride height. So, and how to do bump steer with these plates as well. So, one thing I want to get really clear with everybody is when you're working with your car, remember, the tire is your only fixed point on your race car. Everything that moves is the chassis. The tire stays to the racetrack. So when you're going to do bump steer, and I'm going to kind of bounce around here a little bit, you'll take this plate, the squaring bars that we have here, and just square it up to your setup plate, okay? And I'm just doing it rough here, being live. I'm not going to get precise, but I got a basically 4-inch gap from here to here. And what we're going to do is we will travel the chassis. We'll travel the chassis through the motion. Now, we've just got this car wrecked pretty bad, so we need to see where it is. But we're going to let the car through dynamics. And I know, like max travel, that this would go in there perfect. But for being live, I'm not going to sit there and play with it and get it that damn precise. And we can see here that now we're 4 1/4. And we are 3 3/4. So I got to work on the bump steer on this because I've knocked the right front clean off. You can see is up here, is up there. We've had the rack ripped clean out of the car. We've had the strut mounts ripped clean out. So, but it still is bumping out, okay? Which if you're going to have bump, you want it to bump out anyway. You don't want it to bump in, or you want to get as close to zero as possible. Another thing is, that's how easy bump steer is. Why I do that, and I have the left rear unhooked, and I'll go back here, and I want to talk about a few things that is different on like doing your bump steer the way I do it. I've got the right rear and the left front at the dynamic heights already, okay? So now when we let the right front down, the left rear rised, and I should have showed this before, I'll bring it back, but I had this plate level with the back of the here, so I can measure and see how much wheelbase loss I had. I had this plate square with the plate. Now I can measure how much steer is in it. But getting back to the bump steer and why doing it like this is so important is this car's got a straight bar in it, okay? I don't care if it's got a J bar in it. I don't care if it's got a panel bar back here or whatever. But as the chassis travels, we're going to follow, the chassis is going to follow the path from this point here of the straight bar over to the rear end. So the chassis is not going to go straight up and down. It's going to follow on an arc path like this. So when that happens, it's going to migrate all the chassis around and changes the positioning of the frame, which will actually change your bump steer, to change your caster, etc. So I do know that this car had at ride height had 2.55 degrees caster. None of the stuff's been set because it's been wrecked. So what we're going to do then is we're going to come in here and we'll square the caster gauge to our brake rotor, and the best way is to do it on the bottom side. And like I say, you just want to measure it here, get it in a couple spots. We'll sneak the tape up here and sneak in there to get it. But again, for the live video, I'm not going to sit there and tweak that just perfect, but I went from 2.55 at ride height down to 1/4 degree of caster. I've had caster loss. Why I have caster loss is because as the chassis migrates over and the rear end doesn't shift in these cars, it stays put. To prove it, 2 ways of doing it: go to the racetrack, stand behind a car, rear tire, look at the dirt as they take off, and as the car rises, does the tire track stay straight, or do you see the tire track do this to crap? You won't see it go side to side. The rear end always stays straight in the car, or stays in position of the car, and then it will migrate around the bars. So we got to really put all that stuff into perspective here. Now, I know that we've had a tremendous amount of caster loss in the car. So what I like to do is to put the car in dynamic attitude and get the front end set with our caster, our camber, and our toe. It's where we race at, it's where it lands, so we know it's correct. And I want to minimize the bump as best that I can, but I'm not going to sit here and spend hours and hours to get it perfect. I just want to get it close. And that way, like I say, we're going to put the car in dynamic attitude and see where it is. Another thing that we need to really think about is this is a lot of damn work to put the car in dynamic attitude. I would normally, you can see there, I've got a floor jack, and I would put the jack right here and strut it and have the floor jack going perfectly straight and back, so that way the chassis can move the correct way. But I kind of got hurt pretty good, and it's the son of a biscuit to use the floor jack, so I'm using the electric pellet jack. It's in the exact same way. But it's a son of a biscuit to do this work, and people are always coming back bitching saying, your setup way is great, but it just takes too long. Well, what I would like to say then too is you put the car in dynamic attitude and you get everything set correctly, come back in, take your setup strut that you have, and I've got two different ones because I don't want to be changing heights, but I got one for the dynamic and I got one for the right height here, okay? Put the car back at the right height struts, and then you could have it on the ground or you can raise it up in the air, whatever you want to do. Now you can go back and recheck your caster. You can recheck your toe, your camber, etc. And then that's your new number, so you don't have to run the car through dynamics all the time. Because I understand it's a pain in the ass, especially if you don't have the stands to rise it in the air. It's a pain in the ass to do. Another thing too, if you're going to have stands, make sure, in my opinion, that they are from the floor up 10 inches. Why 10 inches? 10 inches is an easy measurement. I can come over here and go, that is 17 inches. Well, 10 off, that means it's 7 inches off of the ground, okay? So it's just a lot easier system to work with. Let me see what we got here. If you guys got comments, chime in, tell me where the hell you're from, questions, things like that. So, Captain, how you doing, buddy? Damn good dude right there. So you can learn a lot from Captain, and I'm very fortunate to have become good friends with him over the years. So really good guy. But like I say, another tip is once you get your car dialed in where you want it, I don't care if you come off the front bumper horn, I don't care where, but you can put master hard points on your car. I really like the center of the car because you can bend that, and then you can measure off. Let's just use this bolt for example, but you could click off that bolt, come up here and go, hey, now that I knocked the right front off, I can measure off my master point on the frame and get this right front back in exactly where it needs to be. So that's some things I want to talk about and show you, so you can understand how I'm doing bump steer here. When I do the toe of the race car, I like to do it a little more complex. I like to find the center line of the car, and then I will work off the center line of the car and set toe per wheel. That way I know. Now, for example, when this car is at ride height and I want 0 toe, I've marked my setup plate here, and I actually got a doink. I don't think you can see it, but there's a little doink mark right there. Then I can come in here and measure like this, and I've got it marked so I know I can get that back to 0 toe. And then this, say for example, I want the right side 0 and I want the left 3/16. Well, then I can just come in and measure each side and get it set that way too, as a quick reference point. It's just a pain in the ass to do it initially, but once you do it the hard way once, you can make your reference points. It really becomes easy. So another thing that's really important too is to get, when the car is in dynamics, make sure that you set your caster, because I see a lot of cars go down the racetrack and at the very end they'll do a wobble, and if you start studying it and measuring, you'll see where they end up with a negative caster. I'm sure y'all have been to a store and get a shopping cart and you push it and the damn thing wobbles all over. It's because the caster is wrong in the wheels on that shopping cart. Same thing with this. Okay. Another thing I do with my caster gauge that's different, and I want to talk about that, is with my bearings down here like this, if you put the caster gauge here and you turn the wheels 20 degrees of rotation to set caster, my bearing spread is much bigger than the tire contact patch, which will change the rise. When you turn the wheel, it will rise and change and can affect your caster gauge. So I've come up with this gauge to where we have the wheel straight, and we can do caster by simply, like I say, squaring it, turning it on, and reading it. Pretty easy. We can do caster off the top. We can do it off the bottom. Now we can check to see if our spindle is bent in the bottom or top. Another thing we can do, and I've got some things in the way, but I can take this gauge and I can point it and get that out of here. I got to move the brake line, but you take the gauge and you point it that way. And let's say it reads 20 and you put a gauge here, it says 10, take 20 minus 10. That's 10 is the pin inclination of the spindle. Pin inclination being the angle from the upper to lower to where the snout's in the spindle. Okay, it's real important to check inclination both upper and lowers, especially on your sheet metal spindles that bend easy. Now this, I made these spindles out of billet. They're solid, press fit, TIG welded. Yes, they can bend, but it takes a hell of a lot more to bend these than it does the sheet metal style spindle. And there's nothing worse than having a race car that doesn't handle right because you got a bent spindle. And we'll go back to the rear end and talk about axle tubes. Having a bent tube will really give you handling problems. So that's some things to think about. Like I say, do the hard work in dynamics and bring it back up to ride height, and then you can remeasure everything and make notes, and that's your new setup. Okay. And I hope that makes sense to you all about that. Let's go over here to the left rear. You got to build your own notebook for your own race car. I am a firm believer in that. Okay. So what's really cool here is I can take and I can move the bar from here to here and change it on the cage, however, and I can measure all this to see how this changes. So that's really important. Okay. Also, if you want to see if you got a bent rear end tube, you can come in here and see if I can hook it. I should be able to. You got your toe. Now, with this being a pull bar car, it's actually rotated the rear end, so I could look at my toe setting here, and then I would do it up here, and then I could let the car down to ride height, and then that will put pinion angle back in it to see if, as the pinion rotates, if the plates change toe, and if they do, that tells me, hey, we've got a bent rear end, and now we need to investigate, do we have a bent rear end on the left side, right side, and go from there. So it's very, very important. And what's really good here is you build your notebook, you can say, hey, I'm in this hole here, and it creates this much wheelbase loss, it creates this much steer from your plate out to here to here. So you can start making notes in your notebook, go to the racetrack and test, and then you know exactly when I change this bar, it does what. Another cool thing, and didn't bring it, but like on my 4-link cages, I got this plate square, the bottom plate square. You can run it through and see how much cage rotation you have as the chassis rises or lowers. So you can really check the timing out there and go from there as well. I've done a bunch of changes. I don't have the chain set right, that none of that's done. So we got, like I say, I really got tore up pretty bad, just racing deals. And now I'm back chasing stuff, trying to figure out what the hell is wrong. So it's really good to have these tools to do that. So anyway, that's some of the things that I wanted to go over with that, and I hope that that makes sense. You know, why are we using these bars? So we can measure our bump steer, our rear steer in the car, our wheelbase loss or gain, because you can do this on the right rear as well to see exactly what's going on, and go from there. Now, if any of you all got questions about this stuff, you can always send me messages on here. You can call the shop, and the parts department will answer the phone, but they can transfer it back to me if you have technical questions about it. But just wanted to kind of show some of the things that we can do with our setup plates and why. Another thing, I've had some people I've got the bearings on there in the back, going front to back so it can roll, but I don't have it. That style of bearing will hold the rear end in the car side to side the way it is if the tire's on there, so that's really important. And so the front, you can see we've got them this way, so as you run the chassis up and down, it allows the tire to steer in or out. And there is better bearings out there, but the problem is a lot of times the better bearing like that will actually let things move that you don't want move and give you false information. But really important to get a good notebook on this thing so you know where the hell you're at. If you wreck, you can go back. And I just hope there's some tips that can help you guys out and make your race cars better. So, but anyway, we've been doing a couple other things that we got going on. You know, we got our own elements now being made. Guys, it's really important. Our air cleaner elements, no oil. What does that mean? That means you can't over oil the damn thing and get your carburetor full of oil inside and mess up the performance of the carburetor. Another thing I've done is I got one hell of a tight fit between the element and the lid here, and